Section 1.7, we're going to take a look at exponents, at least a little bit of exponents, and order of operations. We will have more information after this about exponents, but this is just a little bit of the beginning part of it. And we've mentioned already order of operations sort of in passing when a couple of things came up. So we've talked a little bit through some of these things already. To start with, exponents is the process of repeated multiplication, and it can be represented through the shorthand use of powers, right, of exponents. So when you have n items being multiplied, you can represent that as a to the power of n. So exponents really are just a shorthand. It's shorthand in mathematics. But to be honest, multiplication is also shorthand for addition. So we use shorthand stuff all the time in math to make it easier for us, less writing, things like that, when we're working through items. So our first example is 3 to the power of 4. Now, again, I totally recognize, and you're welcome to have your calculator out. I'm not picking on Sydney because I just saw her, but you're welcome to have your calculator. I totally recognize your calculator does exponents. So here's what I expect to see. I expect to see you show me that this means 3 times 3 times 3 times 3. That's what it means. And then you're welcome to give me the answer to what that is, and you're welcome to use your calculator as support if you want to move through that more quickly. So what is 3 times 3 times 3 times 3? It's 81. Okay, but I expect to see it written out first. That will be part of what's being graded. The next one with fractions is a bit messier and your calculator is a bit less helpful, but it's still useful. Let me show you. So first of all, because the negative is inside the parentheses, it means that we have negative 2/3 times negative 2/3. If this question said negative and then 2/3 to the power 2, what would actually be multiplied? Yeah, we would have the negative at the beginning, but then we would be multiplying 2/3 times 2/3 like this. So the location of that negative really matters because it will change the value of your answer half the time based on where it is, okay? So we want to make sure that we are interpreting that correctly. The one that we have is a negative 2/3 times a negative 2/3. Now this one's shorthand enough that I don't know that your calculator is really going to help you all that much anyway. It's multiplication of fractions, right? Negative 2 on top times another negative 2, which would give me positive 4.
Positive 4. Whoa.
It's okay. Yeah, be careful. Positive 4. And then my 3 times 3 on bottom would give me 9. Now, if you ask your calculator to do this, it's probably, depending on the mode it's set up when, going to give you a decimal, which is not going to be super friendly in terms of answering the question for me on the paper. So using your calculator for support, like let's say that this had been to the power of 5 instead, right? At the very least, your calculator would be helpful in multiplying all the numerator to the power of 5 and then all the denominator to the power of 5 instead of doing it the whole fraction. Are you with me? Okay? Because this fraction is a repeating decimal. It's the decimal point 4 repeating in your calculator. And depending on your comfort level at moving in and out of decimals and fractions and what those decimals end up looking like, you may or may not actually be helped by your calculator on this problem at all. All right, any questions on either of those? All right. So the other part of the direction set here, or the title of our section, is order of operations. And this I've actually mentioned once before, PEMDAS. P stands for parentheses. E stands for exponents, which we've now discussed, at least in an introductory level. M and D stand for what? Yeah, multiplication and division. I'm going to write multiply, divide. And you'll notice that I have written MD, and then in parentheses I've written DM. And the reason I've done that is because there's actually not a preference on whether you should multiply before you divide. In fact, what you really should do is do the multiplication and division all in the same step, moving from left to right. So you might actually divide before you multiply if that comes before that in the problem. And then the A and S are what?
Addition and subtraction.
Yeah, adding and subtracting. And again, AS could just as easily be written SA. Because again, it's all one step. You're moving from left to right with any addition and or subtraction that are in the problem. We don't add first, subtract second. That is not correct. So taking a look at this, there's also, if you can remember PEMDAS, that's great. Is there another saying maybe, and it's an acronym that you've heard before on this one? Yeah, please excuse my dear Aunt Sally is the most common one. Has anybody had any other one used on this? No? Every now and then somebody will come up with something very creative they learned somewhere in middle school or high school, and it's fun. So that's okay. This is the most common one. So let's do some examples with this. They're going to have parentheses, exponents, multiplication, division, addition, and subtraction, all those things intermixed within different problems. So taking a look at this one, problem number 1, what is the first thing that I will do?
Exponents.
The exponents, right? Exponents comes before division. So the exponent here is the 6 squared. What is 6 squared?
36.
36. So I have 36 over negative 2. Okay, you're going to show that step, the step that you do this exponent part in first. And then what is 36 divided by negative 2? Negative 18. Correct. Is that good? All right. Interestingly enough, I had a previous student, a student who is in med school right now. And he and another one of my students, they're married, and she was an elementary education major. She's not teaching right now, but he sent me a question, all about order of operations, like literally 2 days ago. He was like, Dr. Hands, I realize that this is just so beneath you. He had me for Calc 1 and 2. So this is well under where he has gotten to in math too. He's like, but I saw this, I think you probably saw it on Facebook, and everybody is sort of giving me different answers of what it should be, and I'm interested in your opinion about what you think this should be. So I did an order of operations question for him. He was like, well, that's what I thought I did. He's like, but I've watched 3 YouTube videos now on it, and there's 3 different people saying they're done in 3 different ways. Order of operations is no small thing, and it's really important. The reason it's really important is because if I do the problem in a different order than Kenny does the problem and that Luke does the problem and we get 3 different answers, that's a problem, right? We need to have a universal way that we all do it so that we all understand it in the same way. Number 2, I don't have any parentheses and I don't have any exponents. So what's the next thing I need to be doing?
Multiplication and division.
Multiplication and division from left to right. So we'll start on the left, and it actually happens to be multiplication first. 6 times 2 is 12. Right? So this multiplication. And then I have this division right here. Right? Negative 16 divided by 8. Negative 2. And then I have the addition on the end. Multiplication, division in the same step from left to right. And then that's going to be 12, right? We add and subtract in the same step. So 12 minus 2 would be 10. 10 plus 2 would be 12. All good? All right, number 3. Got lots of grouping symbols this time, don't I? Okay, so not only on this one do I have parentheses, but I also have brackets. So over here in PEMDAS where it says parentheses, it means any kind of grouping symbols, actually, right? Any grouping symbols. So brackets get included in that. So when I'm looking at this problem, and I've got parentheses here, and I've got brackets out here, what I actually need to do is from the inside out. So the first thing I need to do when it talks about parentheses is simplifying inside of the parentheses. So the inside most parentheses here is that 7 minus 8. So 7 minus the 8, I know it's subtraction, but it's inside of parentheses, which is why we're doing it first. 7 minus 8 is negative 1. So I have a negative 1 right here, and then I have times the 6, and then I have times my 2 on the outside. Okay, is that good first? Inside, out. Okay, so we're still inside now the bracket. All right, inside the bracket. And inside the bracket, we have both multiplication and we have an addition piece. Which one am I going to do first? The multiplication piece right here. So this 2 gets rewritten, and I have negative 1 times 6. That's negative 6. So now I have negative 6 here, still inside of the brackets, and then times 2. Okay, now we're still inside of the brackets, parentheses, they're the same thing. Now I need to do the 2 minus 6 part. Yes, I know there's a multiplication, but I'm still doing parentheses, simplification inside parentheses before I move on. 2 minus 6 would be negative 4, and then finally now I have the negative 4 times the 2 at the end, which will give me a negative 8. Okay, is that okay? Definitely messier than the last ones we've been doing. Number 4. What am I going to do first? 5 squared, very good. The exponent will come first. And what is 5 squared? 25. And it's 25 times 3 at the end. Then I'm going to do the 25 times 3, which is 75, you're right. Come on. And then I have 2 plus 75, which gives me 77. Is that good? Okay, looking at 5. What is the very first thing I will do? The inside of the parentheses, which says I'm going to add the 7 and the 2, right? So 7 plus 2 is 9. So now I have 9 squared. You can keep the 9 in parentheses if you like it there, but you don't have to. Now what am I do? What's my next step? The 9 squared, right? It is 81. Yes, and then divide by 3 to give me 27. Y'all good? All right. 6 is a little different because I actually have a division bar. So here's something that I want you to be aware of. When we talk about parentheses, it actually applies to these division bars as well. While they're not written in there, there are understood grouping symbols here and here that separate the numerator from the denominator. So anytime I'm dealing with a fraction written like this with the fraction bar, I have to simplify everything on the numerator and I have to simplify everything in the denominator before I can compare between the two and actually do the division that's there. You could also think of this in a different way. You could think of this as saying 8 plus 4 times 3 divided by 6 minus 2 squared. Okay? You don't have to rewrite it, but that's really what that division bar is saying, is that I have the whole numerator divided by the whole denominator. So when I'm looking at this, what am I actually going to do first in the numerator? The multiplication. So my numerator now has 8 plus 12. What am I going to do first in the denominator?
Parentheses.
The inside of the parentheses. And the inside of this parentheses is the 6 minus 2, which gives me a 4. I can do the exponent. I can actually still keep simplifying inside of the parentheses. So if you want to add the numerator pieces together, because that's a separate part of the problem, you could. The numerator, 8 plus 12, gives me 20. And then the simplification within the denominator, 4 squared, gives me 16. Sorry. Now, 16 and 20, they reduce. What do they have in common? 4. So I can divide them both by 4 using the properties we've seen before. 20 divided by 4 is 5. And then 16 divided by 4, so you're already telling me it's 4. And so this is the 5 over 4 like we got in our last assignment, right, Bailey? So we can leave it as 5 over 4 just fine. That's totally okay. If you really wanted to change it into a mixed number, you could. And if you did, it would be 1 1/4. Okay? All right, I have two more examples, and then I have one more thing before we start working on the homework part. Number 7 is 1/5 plus 6/5 times 1/4. What are we going to do first?
Multiplication.
Multiplication, right? We're going to multiply these together, and we know how to multiply fractions. What do we do to multiply fractions?
You can reduce.
You could reduce across, or Jasmine's saying you can multiply across the top and the bottom. Okay, so either of those will work. I saw both of you at the same time, so let's multiply across the top and the bottom on this one. So I have 6 on this one on top and 20 on bottom, right?
Yeah.
It still would be kind of friendly to go ahead and reduce the 6/20 before I combine it to the 1/5. So let's do that. 6/20 would reduce because they both divide by what? 2.
3/5.
So I have my 1/5 plus what? 3/10. Now we've done an example with fractions with different denominators already today from your homework. In order to add fractions, I need to have common denominators. What would I or could I do to get common denominators here? Okay, so we could multiply them by each other, or we could multiply, what was the other? The first fraction by 2/2. That keeps it smaller, so I'm going to opt for that one. So now I have 2/10 plus 3/10, which gives me what? 5/10. You're already jumping the gun on me here. Thank you, Damaris, you're right. And then it divides by 5 and 5 on top and bottom to give me 1/2. Okay, sorry, I kind of ran out of space there working downwards and ended up moving sideways. Yes, Bailey?
So, is it so okay if we don't, when it was 6 and 20, is it okay if we just leave it like that? And
Yep.
then keep going?
Yep, you'll reduce it eventually. It'll still get the 1/2 at the end. Absolutely. So I tend to reduce things earlier rather than later because I like to work with smaller numbers. But sometimes people just always like to do the reducing at the end, and that's totally fine as well. It would also be fine on this one, like we mentioned, for the denominators here to simply have multiplied by each other and gotten a 50. Or if you had had a 20 and a 5, you would have ended up maybe with 100 as your denominator or something like that if you did it from that perspective. Eventually, it's all still going to reduce down to 1/2 at the very end. Okay, so the intermediate steps, the in-between steps might look a little bit different from person to person, but your answers will match if you've done all the steps properly. All right, last question from your notes. I have 6 minus -44 divided by 11. Division. Okay, so if I'm going to do the division, I've got the -44 divided by 11. So the 6 minus is going to stay. And then what's -44 divided by 11?
-4.
-4. So what am I going to do with 6 minus -4?
You change split.
Yeah, I'm going to add them. So I wanted to throw one in to remind you that we could still end up with double negatives. So this is actually the same as 6 plus 4, which gives me 10. Okay, so pardon me for a second because I'm going to actually show you the question that his name is Evan, that Evan sent me because it was kind of fun. And it is exactly what we're doing right here. So he literally says, super random and sorry to abuse your talents with this. I know it's probably insulting. Need your expert opinion to solve a dispute. He said to solve this. 8 divided by 2 times 2 plus 2. That's the question. Okay, a little bit louder for me, Kaylee, sorry.
You do the parentheses first, which would be 4, and then 8 divided by 2, which would be 4.
Okay, so slow down, let's do it. So she's right, we're going to do the parentheses first, right? Okay, so now my problem looks like 8 divided by 2, and I've got a parentheses here, and then I've got a 4. So then what did you say the next step was, because you're on the right track?
8 divided by 2.
Yes, the next step is the 8 divided by 2, which would give me 4.
And then 4 times 4.
Yes, that's exactly right. And apparently, there are YouTube videos that say that this is not the answer, which I find absolutely fascinating. I should have asked him for, like a reference to see the videos. Any idea what somebody might inadvertently do on this one? What do you think, Bailey?
Distribute the 2.
They might distribute the 2, so across here, that's a possibility. What else might they do?
They might do the 8 divided by 2 first and then distribute the 4.
They might, that would actually, so that would actually work. That's not a problem. We'd still get the same answer by doing what you said. Damaris?
They might do 2 times 4, so then they do 8
Yeah.
divided by 8.
They might look at this and do this first, in part because they see parentheses, and they have a misconception of what that means. When we say parentheses, we mean simplifying inside of them, not just sort of eliminating them altogether. When we get to this point in the problem, those parentheses are nothing more than actually writing it like this. I'm sorry, that's supposed to be a 2 there. I typed with that. Right? They're not parentheses for the purposes of grouping symbols. They're really just parentheses that mean multiplication. So that's a fun one that happened 2 days ago on my phone. All right, so you guys have homework, number 7, Intro to Exponents and Order of Operations. So let's get started with that.